Here we are in a very unusual space, with 6 main windows into neighboring cells. If you look straight up or straight down, everything looks about normal. The cells above and below us are just like the ones we're in. Let's move downward and follow this infinite column of cells as we watch more cells come into view. In this direction, space behaves the way we're used to in everyday life. It's Euclidean. But what about the cells around you to the side? You'll notice something different going on. The 4 cells directly around you look pretty similar to the one you're in, but as you look towards the horizon, they appear to become taller and narrower. Let's go towards the horizon and see what shape these cells actually are. You could think of this as the cells themselves warping and changing shape as we move, but the way I think of it and the way this model was programmed has all cells as being the same unchanging shape to begin with, and it's space itself that is warped. Along the horizontal plane, this space is hyperbolic. It's curved in such a way that there's more room to fit more cells, and that's why they appear squished from afar. Now let's see what space looks like when it's curved hyperbolically in all directions equally. As we move towards the horizon, every cell is still the same, but rather than there being just more room horizontally for more cells, making them appear thinner, there's more room vertically as well, making them appear smaller in height than they really are. In the Euclidean space we're used to, only 4 cubes can fit around one edge, or 4 square-cornered rooms. But here in hyperbolic space, we can fit 6 cube-shaped rooms around a single column. Let's go back to the space that's hyperbolic in just 2 directions and Euclidean in the third. The horizontal beams connect 4 cells, as we'd expect from Euclidean space. The vertical beams, on the other hand, connect 6 cells. Let's start in this olive green cell and move around one of the columns. First, we move straight into a neighboring teal cell. At the center, we'll turn left 90 degrees and go straight into the sky blue cell. From the center of this one, we'll make another 90-degree left turn to move into the light peach cell. From there, 90 degrees brings us not to the original olive green cell, but this coral orange cell. Another 90-degree left, and we're heading into the deep red cell. And finally, our last turn will bring us back to the olive green cell we started in. The path we took around that column was a regular hexagon with 6 right angles. And that's the kind of thing that can happen when your space is curved.